Adding another link. Yeah, I'm referring to the HackChat. A few minutes. Is there, and just throw whatever you want in the HackChat about like what you want to see, any questions you have, etc. Just trying to get a feel for like who's in the room. Are we engineers, mostly just hobbyists, and more the maker community, a little bit of both? What kind of hardware boards are you guys generally working on? And like, what's the board bring up? I mean, I'd probably give. Cool. Well, yeah, I was just asking about the hand assembly, hand placement kind of stuff. And I remember that Dan can definitely relate, like being at the at SuperCon and doing the soldering challenge was just a nightmare. It was really hard.
What were the package sizes again?
All the way down to like 0201. But I mean, it was, it's not your own lab, your desk, you're kind of on a stool. I mean, I can make all the excuses in the world. It was just hard for me. And after you drop one of your components and like the diode, you don't know the polarities, you have to do a quick check. Yeah. That's hard in and of itself. Yeah. Like it's just hard because you could flip the thing, it's so small, and the second it goes, it's gone. Like it.
Yeah, well, like 0201s, I'm pretty sure you can inhale those. Like they can be in your lungs, a couple of them, and it's just not a problem because they're so small. The only time I've ever done those by hand, we took a hypodermic needle and dipped it inside and put that on the bed.
Yeah, reworking 0105 is a nightmare. Yep.
01005. I've never seen one. I don't know if I ever will. I might need to get eye surgery done, dude.
Yeah. No, it's true. It's barely possible. We had to do it when I was working at Taser. We had some really, really interesting fine pitch components that in the interest of time, you just have to learn. And probably the best experience where I learned a lot of this stuff was when I was working, like my first job right out of undergrad was a kind of on semiconductor. And it was just like, that was the best training program that I've ever received and honestly ever seen thereafter for anyone that's like a new grad or early electrical engineer. I mean, people can ask questions here. I just like didn't want to take it away from Hackaday's thing, right? I mean, the whole point is that the HackChat is like something you can go back to and read, and like it's all transcribed. So out of respect for Hackaday and just like keeping things consistent, we want everybody to chat in the HackChat, and we have it open. I'm reading it, and so like it's all good. Like they're being read in real time, and then we're also here on the video. Liam's kind of doing a live demo, so you can do both. That's why. Cool. Explore Scientific USA.
Yeah, I just seen that. Hey, Jerry, we see you.
Yeah, we should find a way to do a cool integration. Microscope is one of the next things that we want to work with. So what sort of features do people design in for debug? Yeah, zero resistor is really, really smart for anything. Yeah, hide your mistakes, put them in. That makes a lot of sense. I mean, depending on the sensitivity of the signal, obviously you have some different like sort of inductance and capacitive properties with those, but for the most part, yeah, it works just fine. That's a really smart way to go about it. You can just pull them out, swap them with whatever, clean, cheap, easy. Other things like adding test points everywhere, super critical. That's generally like, oh yeah, Chris, that's our software. That's inspectAR. That's a product that we've been working on for almost 2 years now. We're selling it in enterprise to basically seriously save companies time and money with the way that you do hardware development, debug, rework, assembly, etc. So whether you have a 2-layer board or a 14-layer board with crazy VGAs, tight packages, really, really tight traces in space and stuff like that, there's no problem at all overlaying anything. And in about 4 weeks, we're launching inspectAR 2.0 with like crazy 3D object tracking and just a lot more advanced stuff. Yeah, dip trace should be fine. We take manufacturing inputs, so it doesn't actually matter. So Cadence, Altium, Eagle, KiCad, etc. And that's one of the other things that's coming out with the free version is KiCad and Eagle users can use inspectAR for free with their boards, and everything else is kind of there's a general kind of price for the enterprise version on desktop, but we haven't figured out. So anybody using KiCad Eagle, you can upload as many projects as you want for free to start, and then go from there. If you want to use desktop, you want on-prem, whatever. 500 test points, no way to put a legend. So yeah, Ragbash, that's a really good point that you bring up, and that's a big part of kind of why inspectAR, this tool that we're using, is a pretty handy tool for bring up and debug, because you don't actually need silkscreen at all.
Yeah.
Like for really tight boards, it doesn't matter.
I think I've got an example
yeah.
of a board like that.
Yeah, exactly. Andrew, for yeah, so you just overlay it. It doesn't really matter. I'm trying to get to these questions in real time as quick as I can. What sort of process involved? Takes about 2 minutes. You literally just put in your manufacturing outputs. For Eagle KiCad, we're making it even easier, just native files. So your Eagle kind of .brd file, your KiCad.brd file, those are just fine. And then we have like on-device, on-prem, but anyone using Eagle KiCad in the cloud is no problem. It's kind of just get done quickly. Layer count doesn't matter, 12, 14, 30 layers, it doesn't matter. So that'll all work just fine. So it looks like it's just about that time to start.
Oh yeah.
Sorry guys, he's a little puppy, but he's having puppy dreams, so it's fine. Yeah, layer count doesn't matter. Thanks, Mark, for being on that quickly. Yeah, I mean, I guess now's a good time to start. I don't know if Dan wants to preface anyway, but I think maybe we'll do like a primer on how we kind of look at bring up, and I'll kind of start guiding it. Liam will show a lot of the stuff on the screen. Using inspectAR more as a way right now just to kind of show what we're talking about, not necessarily like push the tool in any other way beyond like, this is how I would do it, and it's the only way to actually show people via video call.
Yeah.
So, okay, thanks, Dan. So yeah, I mean, basically, pretty much the first thing you want to do, whether your board's been assembled or not, in my experience and just everything that I've seen and kind of heard, is do basic sanity checks first. Don't get crazy with the design or whatever. You don't need to worry about all your different signals and lines. First, check the obvious, like what's going to happen on power up. Is it going to likely blow up or not? So check your power rails. So Liam, in this case, used inspectAR to highlight the 5-volt rail. We'll start with the 5 volts, and that's probably fine for now, just 5 volts. That might get confusing with 3 on top without filtering the second layer. You can filter nets by color and stuff, but for this one, you see the different layers that it goes through, and then based on that, if Liam goes on the right and scrolls down in the info pane, you can actually see him. You can see all the components that are attached as well. So now I have a really easy and identifiable way to say, okay, let me just confirm that my 5 volts are actually running through here, or maybe first do a basic polarity check between 5 volts and ground and make sure that they're not shorted.
Yeah, so I mean, if you're doing a quick check like that, you can just use our search to access your ground very quickly. So here it's really busy. You'd never be able to probe. But if you just want to find a quick, easy test point, what you can do is say, don't show me anything except for pads, and let's ignore all layers except for the layer I'm looking at, the top layer. And then we'll just get a nice, easy, quick test point. No need to go look around in your EDA. And here we can see we've got ground right here, 5 volts right here, and we're actually going to color code all these by net in a later feature so you can get that contrast right away.
Yeah, exactly. So from there, you can quickly find out, okay, here's my ground, here's my 5 volt, do a basic polarity check of just all the power rails and the inputs first, And then also just kind of confirm your outputs, make sure there's a nice high impedance path generally between that and like whatever else you're kind of filtering that into. It's a good idea to check some of your power supply, your power filtering diodes, make sure that there's no gotchas there. Even on some of the LEDs, if nothing's burnt out, there's a very secret low impedance path or something in parallel that you may not have caught at first. That also goes for some of your comms lines when you have your pull up and pull down resistors, just making sure that things are good there, because those will tie directly to the rail, and you could either leave them floating or have other issues. But basically, first thing is like just do a sanity check power supply. So check all your outputs, your inputs, and then even doing like a general like overview of the board itself. Is usually pretty important to make sure the fab or assembly shop or whoever didn't actually screw things up. Like that's usually good, especially some of the larger components or things where you may be like, if this was rotated the wrong way, it would totally screw up, and it's easy to do it backwards.
Yeah.
Things that some assembly shops or even yourself, you could totally do backwards, or just anything with polarity, right? So do a sanity check of all the major like diodes on the board. So in this case, Liam clicked one of the diodes. It tells you what the silkscreen is. You don't need to actually go search for it.
Yeah.
And then oftentimes, like this is something that's happened to me several times. Like, the bill of materials that I was referencing wasn't exactly fully accurate. And so you may have to actually go in, check the part info, and open the data sheet to see the package. Because what happened, like this is an example that I was working on this battery charger board a little while ago. And it was like the wrong extension that was ordered. Same part, same input output, literally just the pins were different. I mean, there's some other small variants that were just irrelevant to me. But that whole thing, I just spent like 2 days being like, man, like this thing is fried. I don't know why my board's fried. I don't know why pin 1 goes to pin 2. It's like, what's in the schematic? It all looks good to me. And then like putting under the microscope or just checking like, wait, this is the wrong part because it ties to pin 3, etc. I could have saved a lot of time if I just had all the info up front and I was able to just put everything in a single space and kind of show. It's the Rigato BLE board.
And this is like a tough board here because if you look at the we can zoom right in with inspectAR as far as the camera will let us. But if you look at the diode on the board, it's got no line on it. But if we go into the data sheet, it shows it with a line. So right away you can get a little bit of confusion, but just clear that up right away and test the polarity of this diode. So like you can see it's regulating a supply voltage down to 3.3 volts. So then that makes it really easy to just go in with our probes and just check that before we power everything up and potentially fry something.
Somebody asked, like, have you tried using inspectAR with AR glasses? Yeah, but that's not really a great business case because you kind of require everybody to buy these glasses where there's no industry standard. None of these guys are even guaranteed to be in business or continue because sales continue to be lower and lower than expected, i.e. Magic Leap. And now the fact that they're kind of up for sale is a bit of an indicator of not everybody wants to buy a really expensive piece of hardware that isn't obviously useful, especially in like an enterprise setting. But the bigger thing was like, just make it easy for people to get onboarded, especially people that don't necessarily have access to the capital or whatever to buy these really expensive devices. So it'll work on those devices. We can make it work on anything. But the thing is, it's a lot easier to just work with an external webcam because you're going to want your desktop to do all the work. And then same for your phone. It's like, don't buy anything crazy. You already have an iPhone or an Android. Just boom. Live view of the board, 3D render, step file, prior design. Yes. So that's actually coming in inspectAR 2.0 is a mobile ECAD. So the idea is that whether you use Cadence, Altium, or anything, you can actually go in and just turn off the AR and literally look at your board, look at your design file without having to necessarily have another license or receipt for your EDA. It doesn't matter. So we take an IPC 2581B files, or in the other case, it's just the standard design file. But now you don't need to have like Eagle on your phone or Altium. You'll just be able to view it and do the same sort of selection and filtering and overlaying that you are seeing here on top of the physical board, just on your phone as if you had Altium or whatever opened on your phone. And those are for quick references for like a firmware engineer saying, okay, where's C5 connected to? Okay, got it, move on.
Yeah.
So there's a big, I'll send I'm probably just going to send everybody this email, or I'll send to Dan. He could distribute it, but we'll work that out for the video recording. Yeah, Liam, you want to show the clock or the C5? Yeah.
You can get that, but you can also, if you're doing hand assembly on a board, this tool can save you a crazy amount of time because when you're doing hand assembly, you normally go like one part at a time. So you've got all your 10K resistors. So now you can go and you can say, okay, give me all of those. Let's just take these and we'll create a batch. And so that's everywhere you need to go and solder 10Ks on this board. And then that's one step of your hand assembly. And then you can move on. Yeah, like clock signals, stuff like that. If you had to do some really tough debug, maybe there wasn't an external point, like you can completely explore your board. So here we've got, I think this is the clock running out of that. Yeah, this is the clock running out of that Bluetooth chip there. So, you know, kind of long signal goes through another layer. And then here we can look and see what it's connected to. We've got a test point. So we can create that one, and then we can go and get the rest of the signal path there. So we've got that full signal on the board now. And what we can do is reference our ground and filter down to just what's needed. We'll go, we can display our ground like that. So this is really busy, like you wouldn't be able to go and fit a probe under here at all. We have one feature where you can go and adjust your transparency just like that to bring it down. And so now you can see underneath, see what you're doing, but it's still too much information. So one thing we have in the tool, I'll just get our transparency back. We've got this edit menu. So you can say, okay, I need to probe something on the top layer and I need to find the closest ground point. Turn off every other layer. Don't show me any traces. Don't show me any vias or fills. Just show me pads. And then right away, you know, okay, here's my signal right here. I can just go and find the closest ground point next to it. So in this case, you know, it's really easy. These probes are way too big, but you've got a pin right next to it. So the pains of a home lab, no really skinny probes around. I guess I haven't checked the chat in a moment, but one thing that I'll go over is that we're running on, so right now what you're seeing is an external webcam, just like Mihir mentioned, but we also work on mobile phones. So we have this great feature where you can go and freeze the camera feed, and then you can even zoom in and move around in order to find what you need and what you're looking for. So we can still, you know, add this switch, request the part info for this switch, and then, you know, open the data sheet for that switch if you needed to go and access info about a component. But on mobile, that frees up your other hand to go and do work. So you can, you know, get yourself set up like this is right now, and then just take your phone and lay it off to the side.
Yeah, and like we said, right now, the way we've been doing it is like the free version does not let you use inspectAR with your own boards. It'll just be with a bunch of preloaded boards that have been given to us by DigiKey, SparkFun, and these other kind of really awesome, I guess, collaborators and backers, whatever, that have been kind of wanting to see us succeed and grow. But in a few weeks, we're launching 2.0. We're on 1.11 right now. So 2.0 is going to have the ability for anybody to just go in, make an account, download it, use it with your own files, etc. Just because we had to work on a bunch of other more critical kind of features in the back end with a couple of key customers and early adopters for the last 6 months. Now we're really growing to scale at the next level with 2.0. So just be patient, but in the meantime, you can use it with Arduino, a bunch of SparkFun boards like the Lime SDR from Crowd Supply and things like that, just to get a feel, and then use it with your own boards really shortly. And if you want to try it now with your own boards, just shoot us an email at there. So that's that. Yep. Any more? I mean, yeah. So pretty much, it's like you just do your power off stuff for the most part. Just go in, do your power rails, check your power ground, do some basic polarity checks on all your major components, like anything that's any sort of large diode or something you see like that. Just go in and make sure that there is a basic sanity check there. Check your bill of materials, and if you're doing hand assembly, I generally like to do assembly by line item, but there's also kind of a school of thought, or you could do it in between or mix of both, to do assembly by kind of area of the board, which also makes a lot of sense because you can test it as you're adding components and things can still work, which is a great way to sanity check and save time. So like naturally, you'd probably want to start with assembling your power supplies. and then checking the input output of all the supplies, making sure you're actually getting 5 volts or whatever where you intend it to be, and doing basic checks of just on a scope, seeing the the cleanliness of the signal and everything like that. Yeah.
I mean, one thing to always do as well, just be like, if you were doing it kind of by room in certain systems, like when you get to this area of the board, you'd want to get all these passives down before you go and try and do this IC, because otherwise you'll have some trouble accessing kind of smallest to biggest.
Yeah, and just let's see what's else. Oh, he was just asking on the HackChat. Yeah, and just like, a lot of times when you go back and you're like, why did it fail or why did it release the magic smoke? In my experience, one of the easiest things to do, and I think a lot of EEs would agree, depending on the board, if you have extras or like whatever, usually if there's smoke, the signal will stop there. So hopefully there won't be too much more damage in the short term. But what you can do is kind of put a higher current limit or just turn it off and just turn the power supply on and see where the smoke starts to really rise. And that'll usually be the spot of at least the most damage, but usually it'll be the source of where the problem area is. And then backtracking from there is a lot easier. So sometimes you can do that, especially if you don't have access to an expensive thermal camera, although FLIR's done a really good job with some of their portable cameras that we're actually working on integrating with into our tool, so you can get some of the digital readings while you're overlaying it over the components. It'll save it, tie into your workflow management, things like that.
Yeah.
Ragabesh, it probably won't work with that microscope right now, but that's something that we're looking into down the road, to have more of a 2-camera setup to allow people to zoom in crazy far while the main board's still in view. But right now, you'll be able to use it for more, probably down to like 201 at best, because it's using a standard 4K Logitech Brio type microscope webcam.
Yeah, this
Yeah,
we're down at max zoom right now. The good thing is that we'll tell you exactly where everything is. So there's no more cross-referencing. Like if you're like, oh, I can't read upside down, I don't know this is R24. We've got you covered there. Just look in the right-hand pane.
Yeah, but I mean, the way, like, the whole board bringer process in general, like the idea, especially with this tool, is to tie it way more into the actual EDAs. So any thoughts you guys have on that would be great. Because the idea is, as you're designing your board, you also want to build up your test interfaces and your kind of structure early on, and go from there. It should work. It probably will by that time. So yeah, I'll just go ahead and schedule a call anyways, a demo, just to see it so we can understand your workflow, and we'll get you set up, no problem, with one of those licenses to get you a trial and see how you like it and see how much time it actually saves you with debug, rework, collaborating remotely now that everybody is separate. Like, that's a huge reason, right? The way that we're interacting with everybody here in the HackChat, you couldn't have done that before in the same way. You'd have to open up your design tool and then post to your board, but like there's not a clear link. Versus now it's just directly superimposed, and you can superimpose anything. So that's the other thing. You can add in custom things into your design to guide people, like different blocks and documentation and things like that. And it goes even further. So there's a lot of interesting things you do with this tool, but ultimately we've seen this go to some pretty awesome companies around the country and around the world in the last year as we've grown the business. And save people a lot of time and money in terms of board rework, assembly, remote collaboration. But at this point, really, it's like we're leaning on this community largely to give us a lot more feedback and thoughts on where you can get more value out of it. So download the free version. Email us if you want a trial of the professional version with your own boards. No problem at all. And we'll get everybody set up. That's totally fine.
I'd be curious to know, of the professionals in the HackChat, how many are working from home labs and kind of still day to day.
That's a great question. Like, how many people now have like home setups, or especially if you're a pro E, are you working from home? Where? Or like, just how is like the whole COVID situation set up? So yeah, you're working on getting a lab set up in the new place. Yeah, so inspectAR would be a great kind of help for that because now you can't essentially travel to other labs. Like that's probably the biggest issue that I've seen with hardware engineering in general. It's that it's incredibly contextual, right? Like it's so contextual, and that's a bad thing in the sense that if you want to relay information to anybody, like even an FAE at TI, for example, because you have a problem with an IC, you have to go take a screenshot of your system, screenshot of your schematic, maybe your layout, go talk to them. It's just a lot of hassle. So this is probably the biggest use case that people are seeing with inspectAR, even for simple stuff like, okay, let me highlight this for you. Okay, can you probe there? There's no ambiguity. You don't need to expect everybody to be a pro at whatever EDA you use or have a license. Just get on a Zoom call, have somebody do it. Boom. Mm-hmm. This is a way that would save you a ton of time with that. That's the idea.
Success story. One customer we had this week where, similar thing. They've all gone home to home labs. Only the lead EE in the company really has like a good home lab set up. And one of their firmware engineers was wondering why he can't get the right kind of I2C packages sent over 2 pins, and they were able to get on an inspectAR call, and it's on this IC, pin 1 is the big circle, not the little one. Like minor things like that, and just something they didn't realize.
Exactly. Yeah, that's the biggest way people are using it with like teams in Canada. Like if you're in the US, like two of our customers, probably the biggest use cases with their team and manufacturing shop in China, and then in Canada. That was a big one. Yeah, in Brazil, we have a couple of customers actually in Brazil using it in a very similar capacity. And then you have like the parts distributors and those guys using it for largely manufacturing or for marketing and things like that, but also just support and walking people through a new piece of hardware. It's a lot easier to do it this way. And like in my experience, when you have a new board, if you weren't the one that designed it, or even if you were, generally not the only designer, and if you were, then other people weren't. So like walking them through the board is always a bit of a challenge because it's just totally unfamiliar territory and there's a lot of complexity. So having a tool like this to break it down and highlight exactly what you're referring to as if you're sitting there next to the person pointing to it is a totally different experience. So that's kind of how it goes over there. Yeah, I mean, like what other tools have you guys found to be really helpful, or what other kind of workarounds have you guys found? So like because of the COVID situation, like working remote or just like collaboration for hardware tools in general, like do you guys use like Fusion 360? I know they have a pretty good platform. Same with like Altium Vault. Cadence has a really awesome one with Allegro Pulse, and kind of get into that PLM, like full workflow management. Do you guys do that? Like, yeah, that makes sense. What about like SolidWorks? What about does anyone here actually use like a workflow management system like Jira for hardware? Because that's always been something that like there's a lot of other startups working on this stuff at the design stage, which is kind of a solved problem because all the EDAs do a really good job of it on their own. And you can collaborate and add comments and everything, but you can't bring it into the physical world unless you have a tool like inspectAR. And so we want to work with a lot of these. Yep, separately on board files, database libraries. Yeah, that makes sense for the components and stuff. Yeah. So that's another thing that we want to find a way to integrate with Cadence and Altium and all these guys, like having the ability to actually go in, have your bill of materials updated, have a local PLM kind of setup. That would be really awesome. But that makes a lot of sense. Yeah, I mean, for us right now, it's like anybody that wants to try this thing out with their own boards, however complex, just shoot an email or join the pilot. So for the next month or two, whatever, you'll get access to play around with the board or with the tool with your own boards. And then afterwards, we're going to be releasing 2.0 with all the new features, new UI, 3D object tracking. It's pretty crazy. Yeah, that's pretty standard. 6 people. That's actually like, well, so Jira for hardware, Dan actually said that when I was at both Tesla and Taser, we used Jira for hardware, and every time mostly unsuccessfully because it's pretty hard. You can't really track progress, but I guess beyond that, it's hard to even know the same process about development because a lot of it depends on like different costs associated with getting quick turn boards, how fast you can design and pass things off. And then when you get the board back, there's so many unexpected, oh, like the board doesn't turn on, or oh crap, I put this wrong and I smoked the board and I'm the only guy here to rework it and I happen to be slower than everybody else, so it's going to take me 2 days versus 1 day, and that pushed everything out. It's hard to do things for hardware. Like, oh, go, a task is assemble a board, but you can't really get people involved with that. Yeah, exactly. But we used it for hardware, and it was kind of like more general, like, oh, like boards in fab. Board came back and now you're doing a board bring up, or this week I'm doing assembly. It's high level, but with a tool like this, you can actually add in very specific tasks and like kind of click them off as you go through them, or as anyone goes through them. Like, okay, assemble the 5-volt supply, very specific, concrete, and you know what happens, or if there's issue, they screenshot it, highlight what's problematic, keeps people in the loop. It's a lot easier to do something that's meant to be incredibly contextual when you have all the context in a single screen. Yeah. Are there any other, like, I don't know, just what else has been kind of, yeah, exactly. You totally get it. Yeah. So Ragabatch, just go sign up. Either way, get you guys like for a demo, like just let's get on a call and understand more how you use it. Get you guys a license, let you try it out with whatever cameras you have, even with your phone, just to get a feel like what would be valuable for you. Maybe give you a sneak peek into the 2.0 version coming out, and kind of the upgrades with zooming, 3D object tracking, like how you flip the board, even some flex stuff and how that works. It's a total game changer. So I would agree. Yeah. Bring up and validation is the biggest one, because now you can get boards fabbed in a day or two. Actually, our biggest investors are Royal Circuits and Advanced Assembly. So just sign up for the pilot so you guys can try the pro version. And obviously on the site, you'll see the free version that's available. Currently, it's just preloaded boards to kind of get a feel on your phone, but in a month, it'll be anybody, KeyCat, Eagle, with more than likely just mobile support. And then for pro users, there's desktop, but the price is nothing compared to an EDA. When you look at it on a Teams level, it's by project, not by user. So if you have a team of 6, it doesn't really matter. It's more about how many boards and how much work you're actually doing. Yeah, you can change the color of any net, whatever you want to do.
Useful. I mean, these ones here weren't they weren't that bad, but if you had something that matched the board a little more closely.
Yeah, but I mean, I don't know, what, maybe even open up the chat. Like, what if people seen as like really good kind of sanity check or baseline tips for bringing up a board, like tools aside to inspect or whatever, but generally like my idea of like when you have smoke, like let it smoke and smoke it so it's really hot. So if you're using a thermal camera, great. If you don't, just almost turn the current limit off or make it really high and smoke it. So yeah, well, I mean, the NDAs, and like we don't actually take yeah, finger is a great one. Just put your finger on it. That test works very well and almost free. Yeah, I mean, we don't actually take the design file. We take the manufacturing output, so it's totally safe. But depending on your organization, we actually do on-device, on-prem. So everything stays local. Obviously, there's more costs associated, but anybody that actually has that level of security, generally, they're buying enterprise software at that level anyway. So that's how we've kind of gone about it. Like some of our guys like Honeywell and other groups like that have been trialing it but needed an on-device kind of a setup. But otherwise, it's all like private. We don't keep any of the files. On the inverse side, if it's drawing no current, start checking. Yep. Yep, clocks and resets, just basic stuff. Oh man, this was like one of the most disastrous time sinks that ever happened to me. It was like I had this crystal connected to my USB kind of enumerating hub, and it would start to enumerate and die, and happen for like 1, 2, 3 days, 5 days. And I'm like, man, I looked at the schematic, I just pasted off someone else's. Long story short, I had forgotten somehow to copy over the bias resistor in parallel with that crystal, and it just killed me. But even things like that, where it's like just the basic elements of the design, the power supplies, the clocks, and the crystal clocks, whatever, just double, triple checks those that they're all set up correctly. And they should have generally like a bias resistor for a kind of external crystal component, things like that.
And so with us, if you're using inspectAR and you just wanted to sanity check a crystal,
Cool, thanks, Jerry.
A crystal is pretty easy to spot. Like this one, I can spot that that's the crystal just by looking at it. And most of us
You can even search.
Yeah, exactly. Just search like X up here, and then you're gonna get all those components. So it looks like there's another crystal on that board. So you've got two crystals. The way I'd explore them is you just come down here and start checking the nets. Okay, so it's grounded there. Let's check the filtering caps connected to it. And here we can see, okay, that's the filtering cap. All right, if we link in the BOM, we can get the value for it, or even we can just request that. Yes, okay, so we got an 18 picofarad filtering cap. Is that reasonable for this crystal? Well, now we can just go in and check the data sheet.
And like all that would have taken a lot more time. You had to go into the schematic, the layout. This is more intuitive engineering. Get your hardware done, work a lot faster. That's really the idea.
So you just come here, Control F is usually quickest. And what do you know, shunt and load, 3 peak. I mean, I don't know the specifics. I'm sure, the 18 was okay for some reason, but if that was a problem, we would have found it pretty quick.
Yeah, or just a lot of people say like, if it works with the design, it's cheaper on the supply chain. I could just order one part in bulk and use it else in the design. That's generally just a good design principle. Like, don't go with all the crazy values. It's just easier to rework and work with it if it's all there. It's not Gerber's, it's IPC 2581B, or if it's Eagle KiCad, it's just the native design file. So in those cases, native design file, we take Gerber X2 with extended comments, which is basically an export from KiCad. But for Altium or Cadence, it's IPC 2581B.
Yeah.
So that's the standard output that a lot of manufacturers are kind of asking for now anyways. It's a pretty clear process.
Yeah, and like Mihir mentioned earlier, the 2.0 version is going to have support for more file types. So if you're on Eagle and KiCad in particular, you're going to get a big upgrade. Just being able to send us that file and get a free project made.
Yep. So Altium, Eagle, Cadence, Allegro, OrCAD, whatever, those are all fine. And then the mobile ECAD applies as well. And, we're considering having just a Gerber viewer if you want to compare it over your board, but it's just more interesting to do it this way. And again, we're not keeping any files. They're all stored in secure servers. We have a whole DevOps security team, like not a shoddy company. We built it up to kind of be incredibly secure and work with some pretty premier customers that you can see on our website. But totally fair question on how we do that. Yeah, this is good. I like that people are coming in and actually asking awesome questions and like taking the time. That's awesome.
Only problem is right now Zoom is blocking some of our hitboxes.
Cool. Yeah. Or Eagle natively .brd kind of thing files, and just kind of how we're going about it. But I mean, ultimately, like, I guess this is another good question to ask. What info? Thanks, Raghav. What info would you guys want to see beyond this? Like,
yeah, is there any kind of like simulation results you guys would be interested in? I know any kind of simulation that relates to position, I think that we could do a really good job on. With like noise, expected heat, stuff like that.
Yeah, like when you hover over a component or whatever, you can say, okay, show me what the simulation was from my Cadence, whatever, and it pulls it up over that.
Because I know one thing I was thinking about is that I think Cadence is soon releasing a free thermal simulator, and so there you can get around like needing a thermal camera. You can just use a thermocouple if you could overlay it with us and just okay, these are the spots I've got to check with just a thermocouple.
Yeah, and theoretically, not even theoretically, we can overlay literally anything. So as we kind of grow, like next up in the product roadmap is a lot of these integrations with some of the tools, but even the ability to upload kind of 3D images in the sense of like you could show a screw going into an actual tooling hole or whatever. So that's kind of how it goes. Net length would be useful finding where high-speed nets go wrong. Ooh, that's a really interesting one.
What was that, net length?
Yeah, I agree. Yeah, I mean, like if you want you have to have matched differential pairs or whatever. Power delivery, like the voltage region, the current. Agreed. Yeah, even being able to block over PDN. So yeah, we could theoretically overlay all these graphics. We just haven't done the integration, but we're pretty closely working with just a lot of the EDAs, just because they know best and they have all the rich data in the tool. So we're working to figure out what would be most valuable to the most users to start, and then add in even more kind of add-ons. And maybe in the near future, actually release or kind of make public like our internal kind of API to have more of a developer region for people to actually go and add in their own tools for a public network is another idea that we've tossed around. But yeah, all this stuff is theoretically possible. The best way to actually see it happen is to just email us and tell us, like, hey, I really want to see this overlaid. And likely you're not the only one. Yeah, net names, you could see that overlaid, but I see even if you just hover over components, but nets, it's a little harder because they're traces, obviously. So that's more of something you'd have to.
Or were you talking more like a logical net things? Like, say we just had this component here, and you had coming out from each pin. If we froze it and we zoomed in a bit, and coming out from each pin, you can get the net name that way.
Yeah. Yeah, so we could turn on those models, or we can actually tie them in. We just haven't made that available, like integration to turn it on. But we could theoretically integrate a lot of that. We've had some interesting stuff in R&D.
Yes, step models. I mean, one thing I see, immediately is just like different packages and whatnot. Like, say this is your board and you need to switch to like a BGA version of this package. You can't have the deleted version. That would be nice to kind of get a step and see what the size change is, things like that.
Yep. Just going through this. Yeah. So this is another thing that we've been thinking about, and we totally have the capacity to do and work on. It's like you have some sort of debuggers involved just in this process, like you have some sort of programmer or whatever, but where issues fall, like even something with JTAG tied in, right? Like JTAG 2.0, it'll let you know where the thing kind of fails or what pins or what components like things are tied to, where you have issues on this hardware design. But now for you to actually go in and read that and then go back to your board, there's a clear disconnect, right? There's a lot of like here, the schematic, the layout, back to board. This would be a way that we want to tie it in. You have all the issues with the problem areas, the nets, the components, the pins. Now just overlay that and maybe in a step-by-step, one-by-one model, have people go through it and say, okay, this is your first problem area. Second one, just like a walkthrough of the board and the issues.
Yeah.
You can already do that with the net names and walking people through it. Now it's just a matter of connecting that in as a custom overlay set and a sequence, kind of like a precursor to our next feature coming out soon called Smart Work Order, that concept.
So we've got this feature coming out where you can just delegate work to someone, like define the steps, and then they can go and do it no matter how little they know about the design. One cool feature I've thought about, though, on the subject of debuggers and stuff is, being able to set a breakpoint in like AVR Studio or whatever, and then when you hit that breakpoint, we just pull up the overlay of like, what that part of the code is accessing on the board.
Yeah, exactly. I'm just looking through the chat. Yeah, 3D board tracking, all that stuff. Yeah, so that's another thing, right? As you get more stuff, this tool actually allow you to actually build out some sort of AOI type software. Because like AOIs and a lot of these things, they're great, but they require a lot of training data. Like, there's companies trying to do this thing right now, but it's like you're not getting great traction because it's not great for small scale, like really prototype board bring up in the lab. It's like when you're at small scale production.
Yeah.
So that's kind of where.
Yeah, a powerful feature, on the subject of AOIs would just be telling you if the DNI components are actually not installed. I know like a lot of people, you've got all your 0 ohm resistors that you did to make it easier and they're listed DNI, but sometimes that can slip through.
Yep. So that's that. Let me see back in the HackChat. Yeah, I mean, rotation of placements, like that's happened to me. I mean, frankly, I've done it wrong, and it's like kind of going through and finding the issue is sometimes taking time, but it also just is how diligent you are in the actual board printer process. You can find a lot of those issues if you're actually going through checking all your inputs and outputs at every single power stage, RF stage, whatever. Just going through that would be actually, it'd save you a lot of time. So that's kind of how we go about it. Are there any more questions, or what do we think, Dan? I don't know how long these usually go, but this has been really great so far. A lot of good questions and awesome feedback.
Loads of like great suggestions on features.
Yeah, really good suggestions. Like these things are totally on the product roadmap, but it helps kind of prioritize things when people actually say like, hey, this would be really useful for me. Mm-hmm. So really exciting, and like thanks a lot for everyone for taking the time. Oh no, we're good for an hour then. Yeah, let's hang on the chat. Bare board connections for probing open shorts before assembly. Yeah, exactly. That's like a really good one in terms of finding like just, I mean, most fabs are doing a basic net list test. Like they don't need to know the net name, right? They're just checking opens and shorts and confirming opens are where opens are, etc. But yeah, part creation library, things like that. So that can happen a lot. But yeah, basic even just sanity check when you get your board back is just confirm all the major nets. There's no odd shorts or opens in them. And usually if you just kind of like have a little test area or something, you can do it. Through hole, blind, and buried vias visualized differently. Not really. You can kind of, we have a little internally like a 3D view. You can boost everything out. But the way you would know that it's a different layer is that you can actually go see what layers is in between. You can see the color differences based on that. And just visualizing it is a little bit different, but you can actually see like what layers a particular via is in between. And generally the easiest way is to see like where it's to and from. Now, obviously, if it's like a different sort of heat, you wouldn't use like a buried via for thermal. You gotta like let the thing go at least blind. But yeah. Or as far as like the full visualization, that's another like thing that we're still working on, just because it hasn't been like the most hotly requested feature is making something go out 3D. But with the new object tracking, it's gonna get a lot cleaner.
Yeah, really, pushing towards our 2.0 and then getting the ability to delegate work really well with this tool made. And I think that'll help a lot of people. And then we're going to start knocking down integrations.
Yeah. Well, look, I think maybe we'll just leave the questions for anybody that kind of wants to come after, and then like just ping, go on inspectAR.com or ping us at always happy to get on a call, walk people through the tool, or just hear your feedback and thoughts on how you would improve the tool. And then how it relates to board bring up, assigning people tasks, walking someone through a task remotely, especially something this tool can help with, but something that we could also use some help with in making that a better process. So that's all I had. I think the video we're going to end, but let's keep the chat going. That might be right, Liam. Let's stay on the chat and let's cut down the demo video just so everyone's in the same place. It's all good. Cool. Thanks, guys. We're still going to stay on the chat. Thank you.